Thank you. Hello, everyone. Today, my report devoted is a study of degradation and cyclic stability of magnetic caloric effect in lanthanum iron silicon system with extra iron and samples without and with addition hydrogen. The work was carried out with cooperation group Professor Feng Xiaohu from Institute of Physics, China's Academy of Science, in framework cooperation grant, and our laboratory staff team. As we know, magnetic caloric effect is used in magnetic cooling technology. Here I show some magnetic cooling device, prototype of some magnetic cooling device. All this one are working same principle. Magnetic material rotated inside with frequency about 4 to 10 Hz. However, magnetic caloric property investigated in constant magnetic field or one time switch on off magnetic field. But what happens it's a magnetic field, magnetic caloric effect in cyclic magnetic field is poorly understood. Therefore, in our opinion, two very important problems must be investigated before creating magnetic cooling device. First problem, investigation of the influence of the frequency of cyclic magnetic field on the value of magnetic caloric effect, and second problem, study of the degradation of magnetic caloric effect under long-term action of cyclic magnetic field. In this report, I will say only the second problem. About samples, few words about samples. As we know, lanthanum iron silicon system is a bright representative materials of giant magnetic caloric effects. In this report, we study by direct measurement system lanthanum iron silicon system with doped presidium, and for detailed analysis, we select two samples with maximum effects, sample without and with additional hydrogen. Also, we investigated by indirect method magnetic caloric effect according to the magnetization date. I will not dwell on this result in detail. It's delta C up to 5 Tesla. Sample without hydrogen, sample with additional hydrogen. I forgot. Addition hydrogen lead to shift TC toward high temperature about 160 Kelvin for all these samples. And our laboratory for measurement magnetic effect by direct method, we use modulation magnetic field method. More details this method you can see in this reference. In here demonstrated different magnetic system can create cyclic magnetic fields. I will talk about it later. Here our sample size, sample with thermocouple and sample in cells. Here results are direct measurements of magnetic caloric effect at high magnetic field up to 8 Tesla. Here samples without hydrogen and with additional hydrogen, and field dependence delta T near the T maximum. Here we see samples without hydrogen demonstrated table-like behavior at high magnetic field, when sample with additional hydrogen demonstrated bell-shaped behavior up to high field. And we observe different behavior field dependence with different saturation field. Samples without hydrogen saturation field about 4 Tesla, and sample with additional hydrogen about 6 Tesla. About cyclic magnetic field, we use AMT magnet system. His magnet just Halbach system, where cyclic field is obtained by the mechanical rotate of this magnets. Maximal frequency in this system about 0.8 Hz. In our experiment, we use 0.2 Hz. And for high magnetic fields, we use linear closed loop superconducting magnetic system with a linear motion actuator. Linear actuator allows the input and output of the samples from the magnetic field with frequency up to maximal frequency 0.5 Hz. In our experiment, we use 0.15 Hz. Result. Here show result degradation effect at cyclic magnetic field 1.8 Tesla. The measurement protocol was as follows. At first, the samples were cooled much lower than TC, and then the samples were heated without magnetic field, the temperature to the maximum effect. As you can see, both samples without hydrogen, with hydrogen, demonstrated slightly degradation. After 90 minutes or about 1,000 cyclics, switch on, switch off magnetic field, we turn off magnetic field, and about after 30 minutes, turn on magnetic field, and we observed the effect is not restored. Our heating, our cooling inside cells also is not restore the value effect. And similar result, but magnetic field 8 Tesla. For both samples, we used we observed good stability at the magnetic field 8 Tesla because magnetic field saturation field for these samples more than 8 Tesla, more than saturation field, but we observed another problem, and magnetic field, most of the samples of this series were broken or hard crackers and strongly cyclic fields. As I said before, in magnetic cooling device, magnetic material will rotate at frequency about 10 Hz. In our laboratory, we create two magnetic system. Magnetic system include 4 magnets with opposite direction magnetic field direction. His magnetic system can rotate with frequency about 30 Hz. Magnetic field maximum 0.62 and 1.2 Tesla. And small video. Video. Now a real experiment. We can investigate it also about 15 Hz. Temperature dependence magnetic effect with different frequency and frequency independence and constant temperature, and it's a real experiment. And results degradation effect for different magnetic field with frequency 10 Hz. We also observe slight degradation magnetic field. It's here too interesting. Number of cycles. It is about number of cycles 128,000 cycles switch on of magnetic field. We can measurement up to a million cycles. This experiment long time about 3.5 hours. In this time, we observed in magnetic field the value effect decreased by the 4%, and for magnetic field 0.62 Tesla, the value effect decreases by 7%. And previous result samples demonstrated magnetic structural phase transition, first order phase transition. Similar samples, but with second order phase transition demonstrated good stability and different cyclic magnetic field. 8 Tesla, 1.8 Tesla, 0.62 Tesla. And my conclusion, our results show that despite the high magnetic caloric value, sample with magnetostructural fast transition may have some problem in cyclic magnetic field. Server distinguish three types of degradation under long-time action cyclic magnetic field. Degradation is associated with incompleteness of the magnetostructural phase transition when the field induced of magnetostructural phase transition not in the entry volume of the sample, when the value of the cyclic field is less than the saturation field. In our case, in field from 0.66 to 1.8 Tesla. Magnetic caloric effect degradation due to the temperature hysteresis, the reversibility of the which depends on both of the width of the hysteresis and on the value of the magnetic field, and irreversible degradation include mechanical destruction of the sample due to gained magnetostruction, as a rule observed at high magnetic field. Thank you for attention. Here our some result about cyclic magnetic fields, Heisler relais, manganites, some materials with gained magnetic effect. Thank you for attention.
I have a question. When you do rotating magnetic field, you have delta T heating, delta T cooling. How is this without cooling system? Why the signal is this stable? Why it is not heating up? for instance, in a first order transformation.
Good questions. For me now, too difficult.
It's very strange. With such with such a velocity, it seems that heat exchange is not enough to keep the constant. This is my doubt.
Maybe right question. More detail about technica we can see in this.
Okay, we can check the direct magnetic. Okay, thank you.